Now we will see how part 4, that is cup of the screw jack, can be modeled. So this is the front view, full sectional front view, and top view of the cup of the screw jack. And as it can be seen in front view as well as in top view. Okay, so this particular part is having hollow cylindrical geometry. Okay, so therefore we can make use of revolve option to create this cup. Okay, so revolve feature can be used for making this cup. Okay, so and whenever we want to use revolve feature, similar to how we did it, how we modeled the body, and how we modeled the nut, and how we modeled the screw spindle, in the same way we can model the cup also. But when we want to model this cup with help of revolve feature, it is important to create the right profile of the cup or the left profile of the cup about its axis. So this is the axis, and with respect to this axis, this is the right profile. Okay, so therefore this right profile will be constructed in the front plane. So let me go to the SolidWorks, select new part. Okay, and then select front plane under the feature manager, then click on sketch. Okay, and then select line command. From the origin, try to draw a vertical line. Okay, and then once it is drawn, okay, so what you can do is select the constructed line. Okay, and then make it for construction purpose. Okay, then what we can do is select a line command. So I'm going to construct the right profile of this cup now. Okay, so in order to create this, I'm going to choose this particular point as the starting point. From this, by treating this as the starting point, I will construct vertical line, then horizontal line, then inclined line, then horizontal line, inclined line, then again horizontal line. So therefore this is going to be my starting point, which will be at a distance of half of 22.5 from the axis. Okay, so therefore let me go for constructing this. Okay, so from here, this is my starting point. I will construct one vertical line, then horizontal line, then inclined line, then again horizontal line, then inclined line, again horizontal line. So this completes the outer right profile of this hollow cylindrical component. Okay, so now it's a time for adding the dimension, but before we go for adding dimensions, I will select the bottom end of the axis line and one of the bottom corner on the sketch. Okay, so select these 2 points and make them as horizontal. Then again select the top end of the axis and one of the top corner of the present on the sketch. Okay, then make them as horizontal. Okay, so once this is done, go for adding height of the cup. Okay, so height of the cup should be how much? 42. So it should be 42. So once this is done, I'm going to add the inner diameter, that is the smallest diameter first. Here it is 22.5. That is the distance from this line to this axis should be half of 22.5. Okay, first add this. Then the next smallest diameter is here 38 actually. Okay, so therefore the distance from this point to this axis should be 38 by 2. I'm going to select this point and this, so it should be 38 by 2. Okay, done. Then the distance from this point to this axis should be 45 by 2. So that I'm going to give it here. So it should be 45 by 2. Done. So then we have to give the distance here as 12 mm. So this particular distance here, let me change it. Okay, so this should be 12 mm. Okay, so then what we need to do is we have to give the outer diameter value here. So the outer diameter, so outer diameter here corresponds to 65 mm. That is the distance from this point to this point should be 65 by 2. So therefore I will select this point and this. So this value should be 65 by 2. So once we do add all these dimensions, you can see the sketch has become fully defined. Once the sketch becomes fully defined, exit from the sketch mode, keep it in isometric view and verify where you have created this sketch. So this sketch has been created in the front plane. If it is confirmed, select the created sketch and go for using go for the features tab, then click on the revolved boss option. Okay, so automatically the software will detect the axis of revolution since we have created the axis already. Then click it OK. Okay, so this is the initial model of the cup. But as we can see in the front view, suppose if I try to take the section, if I try to take the full section along the front plane like this, we can see if you try to keep it in front view, there is no semicircle cutout appearing here, because as you can see here there is a semicircular slot made okay, somewhere here, that can also be seen in the top view. Okay, so this is one semicircular cutout, and this is another semicircular cutout. Okay, like this. Okay, one horizontal, again this is vertical, means when you see it in the top plane. Okay, so therefore we need to make semicircular cutouts on the horizontal plane. Okay, so in order to do these semicircular cutouts, what I do now is I am going to keep it in isometric view first, then I am going to select the front plane first, and then I am going to draw one semicircle on the front plane. So I will select the front plane, I will go to the sketch tab, I will select the sketch option, I will change the orientation of the model to front view. Okay, like this, and then I will select circle command now. So by selecting circle command, I am going to draw, okay, so one circle somewhere here. Okay, and I am going to give the diameter of this circle. So this diameter of this circle corresponds to the which one corresponds to the diameter of this semicircular semicircle here. Okay, so instead of giving diameter, they have given radius. Radius is 5, means diameter should be 10. So therefore I am going to give the diameter of this circle as 10 mm here. Okay, but where this circle should come now, this circle should come exactly on this top line. Okay, is it not, or on the top edge, top circular edge? So therefore what I do now is I will select the center of the circle, and I will select this top edge. By holding the control key, I will select the top face, and then you can see edge 1 is selected, point 2 is selected. Okay, then try to make it as coincident. Try to make it as coincident. Means we have brought the circle onto the top face, okay, of the cup. Okay, then select the origin again, select the center of the circle again, and then holding the control key, select the origin. Now what we do, we will make the center of the circle collinear with the line passing through the, or axis passing through the origin. So therefore I want to make it as vertical. So once we do it, you can see now, okay, the sketch is fully defined. So, and you can verify, you can turn this model to isometric now, and you can see where exactly we have created this circle. It is created on the front plane, okay, which is exactly at the middle of the cup. Okay, so then once it is confirmed, okay, come out of the sketch plane, then select the sketch 2 now, and then go to the features and go for now we need to cut the material, okay, within that circle. So therefore and we need to cut the material on either side of the created circle. So therefore go to extruded cut. Okay, and here instead of blend, instead of cutting towards one side of the sketch, cutting the material towards one side, go for using through all both, then click it OK. Okay, so now if you try to keep it in top view, you can see now, okay, so semicircular grooves can be seen here and here. So this corresponds to actually this and this. Okay, but we need to make same thing horizontally. Okay, so therefore what we need to do, so if you want to get same semicircular groove, okay, horizontally here on the top plane, so then we need to select the right plane. So select the right plane, go for creating one more circle on the right plane. Okay, so keep it in right view now. So similar to what we did it, how we cut the previous semicircular groove, in the same way I am going to create one more semicircular groove with the help of right plane. So give this as 10 mm, and then once this is done, select the center of the circle and select the origin. Okay, by holding the control key, when these 2 points are selected, make them collinear. Okay, and then select this center of the circle and select the top edge, circular edge, and make them as coincident. Okay, so now you can tilt the model. You can see where exactly we have created. It is on the right plane. You can see there it is on the right plane. Then come out of the sketch plane. Okay, then go for a features tab. Select extruded cut. Cut the material on either side of the circle. That is through all both. Then give it OK. Okay, so now you can keep it in top view. This is how it looks. So this is exactly same as this one. Okay, now if you try to keep it in front view now. Okay, and if you try to take the section, full sectional front view, this is how it looks. Okay, so and if you want to change to edges, okay, if you want to come out, if you want to show it in a wireframe, you can show like this. So this is exactly same as this full sectional front view. Okay, so therefore the modeling of the cup is completed now. So let's go for saving this file. So before saving, I'm going to turn off the full sectional front view. Then I will bring back the model to solid form with the solid edges. Okay, and then I'm going to keep this model in isometric view. Okay, and then press Ctrl S and try to save this as the part number 4, that is cup. Okay, so cup is modeling of cup is completed now. So let's go for creating the next part. So next part is washer. Okay, so that is part number 5 is washer now. So where part number 5 is given here. Okay, so actually it is given in vertical orientation, but washer has to be horizontal. So I will rotate the part drawing sheet and I will try to go through this part 5 now. So this is the part 5. So this is the part 5. Okay, so they have given the full sectional front view of the washer and the corresponding top view. Okay, with the help of this front view and top view, we have to model the washer now. So in order to model this one, again, as you can see, it is a hollow washer is nothing but it is hollow cylindrical component. So therefore again we make use of a revolve feature to get this model. Okay, so when we want the revolve feature, it is important to create half of the profile either towards the right side of the axis or which is present towards the left side of the axis. Okay, so what we do here also, we go for creating the right profile. Okay, so right profile, so this is the axis of the washer. Okay, so this is the right profile. This should be this should be constructed now. In the which plane now? Again it should be constructed in the front plane. So I will go to the new part. Okay, so then select the front plane, go for sketch. Okay, so then I will go for drawing a line now. So a small vertical line will be constructed first. Okay, and I'm going to convert this line into axis line. That is, I will use this line only for construction purpose. Okay, so which is shown here. Then what I do is I'm going to construct this profile here. So this profile will be constructed. First I'm going to use this as my starting reference point. Then from this vertical line will be drawn. So, okay, and then inclined line, then horizontal line, then again vertical line, then again horizontal line. So this profile should be completed here. So therefore I'm going to draw my reference point here. From here, draw vertical line, then inclined line, then again horizontal line, again vertical line, then come back to this starting point. Okay, so this completes the this will give us the closed polygon. So once we get this closed polygon, okay, so first again let me go for making this point of the axis and this point on the sketch as horizontal, and this point top end of the axis and this top corner on the sketch as collinear. Okay, so once we do this, we can give the nut this washer height. So the washer height is actually 8 mm here. So we can give the washer height as 8 mm. Okay, then we are going to give the inner diameter first. So inner diameter here is 14.5. Okay, so therefore 14.5 means the distance from ear to ear should be 14.5 by 2. So this should be constructed. Then next higher diameter is 25, as it can be seen here. So that represents that the distance from this point to this axis should be 25 by 2. Okay, so then the outer diameter of this washer is 35 mm. Okay, so therefore I'm going to give the distance from ear to ear as 35 by 2. Okay, so 35 by 2. All the diameters have been entered now. So now it's the time for giving the angle between this inclined line and this axis. So total angle from this inclined line to this inclined line is 90 degree. Therefore, half of the angle will become 45 degree. So therefore, the angle between this inclined line and this axis line should be taken as 45 now. So once we enter these values, okay, we can see that the sketch has been fully defined. Okay, the sketch has been fully defined now. So we can you can see it is showing here its sketch is fully defined. All the lines in this sketch are appearing in black color. That is the indication of fully constrained sketch. Okay, then come out of the sketch plane. Okay, so keep it in isometric view. Okay, keep it in isometric view, and then you can verify where it is constructed. It is constructed in the front plane. Then select the sketch one again, then go for features, go for using revolved boss. Okay, then you can see automatically software detects the axis, so because of which we will get the preview for 360 degree now. Then give it OK. Okay, as you can see in this one here it looks like there is a chamfer. Okay, so unless otherwise mentioned, chamfer should be made with 1 mm length and 45 degree angle. So therefore I will go to the fillet. Under that I will select the chamfer. I will select this outer top edge. Okay, top circular edge. Okay, and I am going to use this as 1 mm. Okay, you can change the value here, or in the left side you can change 1 mm, and this should be 45 degree unless otherwise mentioned. Give it OK. Okay, so this is so this completes the modeling of which one, washer. So if you want to check the views, you can keep it in front view. You can take the section, okay, and give it OK here. So this is how it looks. And if you want to change the, if you want to see it in wireframe mode, you can check it like this. Okay, so this is how it looks, and in the top view it is going to appear like this. So this is the only half section, so you can turn off the section like this, and then it is going to appear like this. Okay, you can see 1 2 3 4 circles are there. Here also 1 2 3 4 circles are appearing. So this is the top view, okay, of the washer, which is exactly same as top view given here. So this completes the modeling of washer. That is part number 5. So let me keep it in isometric view, change the display style to shaded with edges, then press Ctrl S and go for saving this as part 5, that is washer. Okay, then close this window. Now we go for modeling the part number 6, that is CSK screw. Okay, so CSK stands for countersunk screw. Okay, so let's try to look at CSK screw. So it is given here. Okay, so again it should be in vertical orientation, so I will rotate the part drawing sheet. So now you can see, so this is, so this part is actually the CSK screw. So this again, this screw is nothing but again it will have cylindrical geometry. Okay, so therefore again we make use of revolve option. Okay, similar to all the previous parts of the screw jack. So it is important to construct only the half of the profile, but in this case screw is not hollow component, hollow cylindrical component, it is a solid cylindrical component. So therefore there is no need to construct the axis. Okay, so I'm going to take the axis as the solid line, then horizontal line will be constructed, then this inclined line, then again vertical line, then again horizontal line. So this right profile of the screw will be constructed with respect to its axis. So select the new part. Okay, okay, I will change this background to plain white, and then select front plane. So sketch has to be constructed in the front plane, then select line command. Okay, so then draw one vertical line, then so this vertical line corresponds to the axis here, axis of the screw. Then next we are going to draw the top face of the screw, that is this horizontal line. So horizontal line will be constructed, and then from that inclined line will be constructed here. Okay, inclined line will be constructed like this. Again vertical line, then come back to the starting point. So this is how the outer profile is going to, or the right profile of the screw is going to look like with respect to its axis. So then I'm going to give the dimensions now. So height of the screw is 30. Okay, as you can see here, the height of the screw is 30 here. So give this vertical line length as 30, and then Now I'm going to give the inner smallest diameter first. Smallest diameter is nothing but this part. Okay, so but here it is giving it as shown as M12, means this portion is having thread. Okay, is that because it is a screw, so there will be external thread with the nominal diameter of 12 mm. Okay, so the major diameter of 12 mm. Okay, so therefore this 12 mm diameter should be added first. Okay, but here we need to give this as radius 12 by 2, it will come as 6, and then we have to give this as outer. So the on the top of the screw, the diameter of the screw head is 24 mm. So therefore I'm going to give this one now as 24 by 2, and then we have to give this angle here. Okay, angle is 90 degree, therefore half of the angle is going to become 45 degree. So once we do this, the sketch has become fully defined again. Okay, so sketch has become fully defined, so we can come out of the sketch plane. Okay, and then we can go for keeping it in isometric view. Okay, and then you can check where it is constructed. This profile is constructed in the front plane. Then select the sketch one again, then go for features. Okay, then go for revolved bars. Okay, and then now since we had not created the axis for this sketch, okay, so we have to manually select which is the axis of revolution. So axis of revolution in this case is this vertical line. Okay, so I'm going to select this vertical line, then preview will appear like this. So then give it OK. Okay, so this is the initial model. Okay, based on our right profile of the screw. Okay, so then what we need to do is, as you can see here in the front view, there is a rectangular slot appearing. Okay, and this in the top view we can see that this rectangular slot is having a width of 2 mm, and in the front view we can see that it is having a depth of 3 mm. So therefore we need to make a rectangular slot so that this screw can be operated with a screwdriver. So in order to insert the tip of the screwdriver, there should be a slot in the head of the screw. So therefore that rectangular slot has to be made now. In order to do that, again I'm going to select the front plane first. Select the front plane in the feature manager tree, and then go for creating a sketch. Okay, in the front plane, keep it in front view. Okay, and after keeping it in front view, what I do now is I will select rectangle command. I have selected rectangle command. I'm going to draw one rough rectangle here, and the depth of this rectangle should be how much now? The depth of the rectangle can be seen in the front view. It is 3 mm. Okay, so give it as 3 mm here, and the width of this rectangular slot or the rectangular groove should be 2 mm. So therefore this can be taken as how much? 2 mm. Okay, so but it has to be, this rectangle needs to be aligned, okay, properly with the screw head. So how it should be aligned now? So what I do now is I'm going to zoom out here a little bit. Okay, so now I'm going to right click on this horizontal line. Okay, I'm right clicking on this horizontal line, and by right clicking on that I'm going to select the midpoint of that horizontal line. Okay, in that rectangle. So you can see I have selected midpoint of this line here. Okay, so you can see that one. So horizontal 3 is selected. Then I'm going to hold the control key, then I will select the origin. So select the origin. Now you can see point 1 is selected. Okay, so point 1 is actually on this horizontal line of this rectangle, and point 1 at origin means this one. So now what I do, I will make this as between these 2 points I will add a vertical relationship. They should be on the same line. Okay, but then what we have to do, again I'm going to select now the top end of the midpoint of the top line, top horizontal line in this rectangle will be selected. Okay, in order to select that midpoint, I'm going to right click on the top horizontal line of that rectangle, and I'm going to select the midpoint. Okay, once this is done, okay, then holding the control key, I'm going to select the top edge of this screw head. Okay, so this top circular edge will be selected. Once this is done, you can see edge 1 is selected, point 1 is selected. These two should be what? Coincident. Give the coincident relationship, so that that rectangle comes and fits to the top face, something like this. Now you can see where we have constructed this which one, rectangle. So it is going to appear like this. Keep it in isometric view. Okay, so then what you have to do is once this is done, now you can see sketch is fully defined. Come out of the sketching mode. Okay, it is created exactly at the middle of the screw head. Then go for features, go for extruded cut. Okay, we have to make a slot now, rectangular slot or groove. So we have to remove the material within that rectangle. So use this through all both side. Then click on OK. So this will make the rectangular slot in the screw head like this. So now you can keep it in front view. This is how it looks. Okay, so you can see now you can compare the front view here and here. So both are appearing the same. And if you want to check the top view, you can keep it in top view and you can check it here. So this is appearing like this. Okay, so this is how the screw is going to appear. Okay, in the isometric view now. Okay, but in addition to this, this rod portion of the screw should carry the which one, external thread with a diameter of nominal diameter of 12 mm. So for showing the thread, again we are going to make use of cosmetic thread here. So in order to use the cosmetic thread, I will go to which one, insert here. I will go to annotations. I will go to cosmetic thread. And then again first it will ask from which circular edge we have to give the cosmetic thread. So I'm going to select the bottom circular edge here. Okay, from this bottom circular edge in the upward direction I have to add the thread. Okay, but up to what distance we have to add the thread? Okay, so up to somewhere here, but you can see, as you can see here, somewhere here the thread is not provided. So therefore thread should not be given for the entire length of the rod. Okay, so some 3 mm, they have not specified what is the distance for which thread should not be given. Okay, so we are going to assume it as 3 because the distance from here to here is actually 6. Okay, as it can be seen here, it is 6. Okay, total height is 30. Therefore, the distance from this line to this line is 24. So I'm going to leave around a 3 mm gap here. Okay, so I'm going to give the thread for 21 mm length from the bottom circular edge. So that is what I do. I'm going to use blend and I'm going to use it as 21. Okay, so and here I'm going to use instead of M8, I'm going to use M12. Okay, so this is done. Then click on OK. But again, you can see if you try to expand this cut extrude one, revolve one here, if you try to expand this revolve one feature, you can see here somewhere here cosmetic thread is appearing. Okay, means cosmetic thread is showing here in blue circle. Okay, so it is there, but we are not able to visualize it. So what we do, we go to this SolidWorks option here on the top. There we go to document properties, go to detailing, then go and choose shaded cosmetic threads. Then click on OK. Press enter and click on OK. Now you can see cosmetic thread has been placed on the outer surface of the rod portion of the screw. Okay, so this is the rod portion of the screw. In this rod portion of the screw, we have provided the cosmetic thread. Okay, and again, if you try to carefully look at this screw, on the bottom side of this screw, on the bottom end of the screw here, okay, there is a chamfer. Okay, for alignment purpose or easy insertion purpose. Okay. So what we do is we need to add chamfer here, unless otherwise mentioned. This chamfer should be made with a length of how much, 1 mm and a chamfer angle of 45 degree. Give it OK. Is that clear? So this is how we can go for making this. So keep it in front view now. You can verify there is a chamfer provided here. Okay, so thread has been provided from here to here. Some for this much portion, that is for 3 mm portion of the rod length, we have not provided the thread, which is same as this front view of the screw. Okay, so therefore this is the front view of the screw, and this is going to be the top view of the screw. And you can see here there is a partial circle appearing, which is the indication of there is a thread. Okay, is that clear? So now you keep it in isometric view and save this file as part number 6. That is part number 6. It is screw, CSK screw, that is countersunk screw. Okay, so keep it in isometric view, save it, and then close this one. Now it's the time for modeling the last part in the screw jack, that is part number 7, that is Tommy bar. Okay, so this Tommy bar needs to be modeled now. So let's try to check where this Tommy bar is. So here, so this is the Tommy bar, only one wave is given here. Okay, so again it is having diameter of 12 mm on the left, diameter of 20 mm on the right, and in between there is a step with a step angle of 45 degree here. Okay, so therefore for some length of the Tommy bar, diameter is 12 here for this 62 mm length. Then for the remaining length the diameter is 20 mm. So therefore and also it is not hollow cylinder here, it is a solid cylinder. Okay, it is a handle. So therefore we can also model this one with help of revolve feature. So therefore what it says is all the 7 parts of the screw jack can be modeled by using a revolve feature. So therefore whenever we want to use the revolve feature, we need to create the right profile or the left profile of the component from the axis, or top profile or the bottom profile, or that is upper profile or the lower profile of the component from its axis. So since this Tommy bar is in horizontal orientation, we have to create this upper profile. So this upper profile, that is from starting from here, draw vertical line, then horizontal line, then inclined line, then again horizontal line here, then again vertical line, then come back to the starting point. So the upper profile of this Tommy bar has to be constructed with respect to its axis. Okay, so therefore what I do now is I will select new part. Okay, so I will select the front plane. Okay, go for creating a sketch in the front plane. Select line command. From the origin draw one vertical line first which corresponds to this here, then draw one horizontal line. Okay, so draw one horizontal line, then draw one inclined line here, approximately inclined line, and then I can go for drawing another horizontal line, bigger line here, so up to somewhere here. Okay, and then you can draw one vertical line and come back to the starting point. Okay, now what we can do is we can also go for okay, first let's add the dimensions. Later we are going to give this round shape here on this side, and we give the chamfer on this side. Okay, so first let's add the dimensions. So first I will define the overall length of this Tommy bar, which is 275 mm. So I'm going to give this as 275. Okay, so overall length of the Tommy bar has been given, that is handle. Then what I do is I am going to enter this portion. This is how much? 62 mm. So this portion of the Tommy bar should have length of 62 mm. Okay, and then this angle should be 45 degree. So select this inclined line, and somewhere here you select this vertical line, so that angle between these two should be 45 degree. Okay, and then what I do is I will give the diameters. So on the left side the diameter is 12 mm. Okay, so I will select this line, and this should be 12 divided by 2 because we are creating only half of the profile. Then on the right side the diameter will be 20, therefore this height should be 20 by 2. Okay, so now you can see the sketch is showing underdefined still, but I have entered all the dimensions, but still it is showing underdefined. So let me zoom to some of the corners here. I think this corner looks to be fine. So let me try to, okay, so if you try to observe somewhere here, okay, so you can see there is a blue color point appearing. Okay, so you can see there is a small horizontal line which is which has been constructed okay, unknowingly. Okay, because when we were clicking the left mouse button, okay, so this line has been created unknowingly, so we need to delete this one. So let me select this line. Okay, so delete that one. Now you can see that the sketch has been fully defined. Okay, once we deleted that small line which was near the origin, you can see the sketch is fully defined now. Okay, but we need to give also this round shape here. Okay, so instead of having flat face on the right side, so we need to get the curved or the spherical shape. So in order to get this one, what I do is I'm going to select circle. I'm going to select circle command. Treating this as the center of the circle, I will construct one circle here. Okay, like this. And then what I do is I'm going to extend this line from here to here like this. And then what I do is I will select this vertical line which I had constructed earlier, and I will use this only for construction purpose. Okay, and then I will use, there is option called as trim entities here. Select trim entities, try to trim this part. Okay, and also try to trim this part. So therefore now we have left with this arc, but I need to draw line from here to here. Now you can see the sketch is complete. Okay, and it's showing fully defined. Once you get this kind of profile, okay, then you can come out of the sketch plane. Okay, you can see this is what we have constructed, but here somewhere here there is an axis line. This is only for construction purpose, you can ignore it. Okay, software will not detect that. Okay, so we have a closed polygon now, so therefore we'll go for features. I will go to revolve. But here again we had not constructed the axis of this Tommy bar, so we need to manually give which is that axis. So I'm going to select I think line number 5. So let me clear this first. So I will select this one. So that is line number 6 has to be selected, okay, as the axis. And here it is also not software has not automatically detected the which one the profile about which the material needs to be added. So I will select this profile as, I will go to this select contours. I will select this contour now. So this is the option, okay, this is the field where you have to select the profile. So once we select that sketch 1, okay, so we can get this profile here. I think here we are not getting the profile, maybe because we have created 2 lines. So let me first verify. Okay, even though we have done this somewhere here we are not getting the spherical shape. Let me quickly identify where we went wrong. So whenever you want to edit the already created model, so in the feature tree you go to the revolve one. Okay, under that you will find your sketch. Okay, go to the sketch 1, go for edit sketch. Okay, so somewhere here I think I created 2 lines. Okay, so let me select the line here. I will try to delete this line. Okay, so as you can see here I had created 2 lines. So let me keep it in front view. During the construction of that sketch, from this point to this point I created lines twice, because of which, okay, the software could not detect the area properly. So I have deleted one of the line now. Let me go back. Okay, and now it is asking for the features. I will select even this. So this is another contour. Okay, so you can add it and then give it okay. You can see now. Okay, so this is how we can get the spherical shape. Okay, spherical shape to the right face of the Tommy bar. Similarly we can also go for giving the chamfer here. Okay, so the chamfer can be given with the help of this command, 3D command, and unless otherwise mentioned, always chamfer should be 1 mm. Okay, with 45-degree chamfer angle, give it okay. So you can see now chamfer has been given. So keep it in front view and verify. Okay, so whether you have given the chamfer here, okay, and whether you have made it as a spherical shape. See, they have not mentioned exactly what is the diameter of this curved surface here. So you can go like taking this as a curved surface with radius equal to radius of this Tommy bar in this zone. Okay, so that is what you can do. So this completes the construction of Tommy bar. Okay, you can keep it in isometric view now. Okay, so then save this as part number 7, which is Tommy bar. Once this is done, okay, so you can see and also here in this, on this Tommy bar, they have for gripping purpose they have done knurling operation. It is a manufacturing operation which cannot be shown. We can do that, okay, but again it takes time. Okay, so I will not tell about how to model the knurling over the which one gripping portion of the Tommy bar. Okay, is that clear? Okay, so this completes the modeling of all the 7 parts of the screw jack now. So let me close this one. Now it is the time for assembling all the 7 parts that we have modeled so far one by one. So therefore now let me explain about okay, how the parts will be assembled. Okay, first we are going to take the body into the assembly file. We are going to import this body to the assembly file. Then onto the top of the body we are going to fit the which one nut. Okay, so this nut will be fitted onto the top of the body. Okay, and then into this nut, then we are going to insert this screw spindle, because this thread portion of the screw spindle will go inside the nut. Okay, then means the spindle will be placed okay, into the nut. Then onto the top of the spindle here, onto the top of the spindle, the cup will be placed. Okay, and then okay, when the cup is placed on the top of the spindle, okay, so it will be locked with the help of this washer and the screw. Is that clear? So cup will be placed onto the top of the spindle, then this washer will be placed on the which one on the spindle head, and then we are going to insert the CSK screw into this hole. Okay, hole made in the spindle. Okay, so then we are going to insert this Tommy bar into the hole which we have made in the spindle here. Okay, so this Tommy bar will be inserted to this hole. So let's see how that can be done in the software now. Okay, so this is how the assembly of the screw jack will be done. So first onto the top face of the body, nut will be fitted. Then means it will be fitted tightly. Then into the nut this spindle will be inserted. Then on the top face of the spindle, cup will be placed. Then cup will be locked with help of this washer and the screw. Then Tommy bar will be inserted to the head of the spindle for the rotating the screw. Is that clear? So this is the assembly process. So let me now demonstrate about how to do this assembling. So go to the SolidWorks, go and click on new. But now instead of doing the part modeling, we go for assembly creation. Go for assembly. Okay, then click on OK. So this is the working window in the assembly. So same as our part modeling. So here I will change the, okay, I think here we don't have option to change the background color. Okay, let me go with this default color of the background. So now what we need to do is we have to import the parts one by one. Okay, we have created 7 parts. These 7 parts can be imported okay, all at once, and then they can and after that we can give some assembly relationship. Okay, otherwise we are better, it is better to go for importing the parts one by one, so that we can avoid the confusions. So once this layout opens, okay, so what you have to do is here you go for clicking on browse. On the left side, okay, begin assembly is there. So there you go to browse. Okay, then you select the body first. Once you select the body, you can see now the body that we had created earlier, okay, is appearing here. Okay. Okay, so now this body has to be placed, this body can be placed anywhere in this assembly layout. Okay, but I am going to place this exactly at the origin. Okay, so how to place it exactly at the origin of the assembly layout? So that can be done. So what you need to do is you have to take the cursor onto this feature manager design tree here. Okay, once you click on that, in this assembly layout, this assembly one will appear. Then you click on this plus sign here, then click on this origin. Okay, so click on the origin. Then the origin of this body will coincide with the origin point of this assembly layout. Okay, is that clear? So this is what you need to do. So that now we have imported the body of the screw jack exactly to the origin point in this assembly layout. Okay, so then what we do is we are going to import the next we are going to bring the next part that we have created. That is, so in order to bring the next part, what I do is there is option here called as, so in this assembly tab, assembly command manager tab, there is an option called as insert components. Click on insert components. Okay, then go to browse. Okay, then select the nut, bring the nut and place it somewhere here. We can place it anywhere. Okay, in this layout. Okay, we can place it anywhere around this body which we have already placed. So now I am going to place it somewhere here. Then what I do is first I am going to establish okay, I'm going to explain. I'm going to establish concentricity okay, between this cylinder and this cylinder. That is, I'm going to make the axis of this nut collinear with the axis of this body so that it can be easily inserted. Okay, the axis of this nut should be made collinear with the axis of the body. So how it can be made, I will explain now. So go to mate here. So in the assembly command command tab. Okay, so go to mate now. Click on mate. Click on mate now. Then okay, what you have to do is select this lateral surface of the cylinder here and also this inner surface. So once you do that, okay, you can see now when you select the phase 1 and phase 2 of the two parts between which some mating relationship to be added. Okay, when you select those two phases, okay, we can see we have these many possible mating options. We can make them parallel, we can make them perpendicular, tangent, concentric. But right now I want to make it as what? Concentric. So I will go for concentric. Okay, and then I will click on OK. You can see now. Okay, so if you try to look at this nut now, okay, it can be moved up and down, but you cannot move this one left to right. Okay, because we have made the axis of this nut collinear with the axis of the body. That is, we have made, okay, this cylinder concentric with this cylinder. Okay, is that clear? So that is what you need to do first. Then what we do is, okay, so I'm going to bring this bottom face of this collar in contact with this top face of the body. So in order to do that, so I'm going to select the mate command again. So I'm going to select this bottom face here and then this top face. Done. Okay, but again, see, first we created the horizontal motion, then now if you try to move this nut now, it cannot be moved. But if you look at carefully, okay, this nut can be rotated like this. Still it is having a degree of freedom. It can be rotated. Okay, it can be rotated like this, but it cannot be seen because of some visualization. So but you can see that it can be rotated like this about the axis of the body. So we need to prevent that one also. In order to prevent that one, what I do is, okay, so you can see here, go to the mate again. So here select the front plane. So I will keep the entire assembly in the isometric view. Then I will select the front plane of the assembly. So you can see here, so front plane of the assembly has been selected under mates here. Then I will go to the part 2. Okay, I am going to expand the part 2 here. Okay, and then I will select the front plane of the part 2. When you do that, you can see now the front plane that we used for creating the nut, okay, and the front plane of the assembly layout, both have become now parallel and coincident. Okay, so once we lock this one, okay, then there will be no degree of freedom for rotation of the nut. Okay, so this is what you need to do. So we made the front plane of the nut coincident with the front plane of the assembly, that is this one. Okay, so this completes the insertion of the fitting of the nut into the body. Okay, once this is done, so we have to bring the next part. Next part is which one? Go to insert components, go to browse, then take the screw spindle. Okay, now you can place it anywhere here. So first I will place it somewhere here. Now, okay, so now what I do is first again I want to make this cylindrical portion concentric with this cylindrical portion. So how to do that? That is, axis of this spindle should be collinear with the axis of this body. Okay, so how to do that? Go to mate. Okay, select this cylindrical portion. Okay, and then the inner cylindrical portion here. Once you do that, both will become concentric like this. Then give it OK. Okay, so then what can be done is I can go for selecting I want to give some distance, okay, between this face and this face. So in order to give the distance between these two, I will select this bottom face of the which one, screw spindle head here, and this top face of the nut. But when you select those two, automatically it will take a coincident option. But if you don't want to make them coincident, and if you want to show some portion of the screw thread, okay, out of this body, then what you have to do is you should go here, instead of coincident, I'm going to give the distance between. So right now when we say it as coincident, distance between the two selected faces is 0, but I don't want the distance to be 0. So I will go for clicking on this horizontal distance here, that is the distance. I'm going to give this distance as like 35 mm. Okay, so then give it OK. Is that clear? So now right now we have given the distance between this face and this face as how much? 35. Okay, so then but you may think that it has been inserted, but still we have not restricted one of the movement here, that is this one. It can rotate. You can see here, see the function of the spindle is to rotate. Okay, but here in order to get the proper orthographic view, okay, it is important to bring this particular wall exactly exactly at the middle of the front view. That is, if I try to keep this in front view, so this wall should be exactly in front like this. So in order to get this one, it is important to again lock the rotation of the spindle. Okay, how the now the question is how we can go for locking the rotation of the spindle. It can rotate like this, but its rotation should be locked. How it can be locked now? Okay, so go to the mate. Okay, so again select the front plane of the assembly, and then now go and expand the part 3 here. Expand the part 3 features. So and in part 3 select the front plane. So try to make the front plane of the part 3, that is screw spindle, coinciding with the front plane of the assembly. Select that one. You can see now these two, front plane of the assembly and front plane of the part 3. Okay, both have become coincident. Give it OK. Okay, now if you try to rotate this one, it will not rotate. If you try to move it up, it will not move. Okay, if you try to move it to the right side, it will not move. So it's completely constrained. Okay, so therefore close this. If you try to keep it in front view, it is going to appear like this. So exact front view will be obtained with this wall exactly at the middle. Okay, so therefore this is the isometric view. Now we are going to bring in the next part. Okay, so which is the next part now? Go to insert components, browse. So try to pick the, which one? Try to pick the cup. Okay, so the cup has to be placed above the spindle. Okay, so here above the head of the spindle. So therefore what we do, once we import this one, go to mate. Okay, so what I do is I will select this circular edge here and this circular edge, and make them concentric. Now we can still move this up or down. Okay, we can move this up or down, and it can be rotated like this. So this degree of freedom should also be restricted. It should be removed. So this degree of freedom can be removed by selecting this bottom face. Now you can see the face one is selected. Okay, and this top face, because this is where it is going to rest. Okay, so then there the distance between these two selected faces should be 0. Give it OK. Okay, so done. But still it can rotate now. We cannot move this up or down, but it can rotate now. So in order to prevent the rotation, because when I try to keep this in front view, my objective is to get this semicircular groove exactly in front like this. So in order to get that one, the rotation should be locked. Okay, so this is just by keeping orthographics view in mind, because in reality the screw spindle has to rotate. Okay, we cannot restrict the rotation degree of freedom of the screw spindle. Okay, so you need to remember that this is just to get the proper front view and top view and side views. So now what I do is I'm going to when we are in the mate options, I will go and choose the front plane again. I'm going to expand the part 4, and I will select the front plane of the part 4, and I will make them a front plane of the part 4, front plane of the part 4 and front plane of the assembly. Both are coincident now. Give it OK. So now you cannot rotate, even you cannot rotate this. Now if you try to keep it in front view, you will get the exact view, okay, of the screw jack assembly with this wall at the middle and this semicircular groove also at the middle. Okay, or exactly they are on the right plane now, because where is the right plane? You can see this is our right plane. So right plane, so these two are this right plane is actually acting like axis of the body, and axis of the spindle, axis of the which one axis of the nut, as well as axis of the which one air cup. Okay, so this is how you can go for assembling the first four parts. So now what we have to do is we have to bring the washer first, and we have to place the washer on this top face. Okay, and then we have to put the screw here. So in order to do that, so let me go for inserting the components. Click on insert components, go to browse, pick the screw, first pick the washer and bring it here, and then select this circular edge, and then select this circular edge. First go choose. See, once you bring the which one? Once we bring the washer to the assembly layout, okay, go and click on the mate, and then you select the circular edge. Okay, you can see edge 1 is selected of part number 5. Then I'm going to select this edge of part number 3. Okay, you can see now these two. Okay, so these two have become concentric, means the axis of the washer and the axis of the cup are collinear now. Give it OK, and then what we have to do, we have to select the bottom face of the washer, and then select the top face of this spindle head, and then give it OK. But still again this can rotate, still this washer can rotate. So if you want to prevent the rotation of the washer, so as I was telling, first select the front plane of the assembly layout, and then select the close this part 4 now, expand the part 5. Okay, so select the front plane of the assembly. So you can see, you can keep it in isometric view. Okay, so this is how we are aligning the front plane of the washer with the front plane of the assembly. Give it OK. Okay, so therefore therefore you can see now similar to how we were checking whether the sketch is fully constrained or fully defined or not when we were modeling the individual parts. In the same way, you can also check the status bar during the assembly process. You can see here even the assembly is fully defined now, means all the assembled parts are completely constrained. Okay, completely constrained with respect to each other. There is no degrees of freedom available between one part to the another part. That is what here it is representing, fully defined. So whenever it is fully defined, we will get the good orthographic views. But only thing is, if you fully define it and if you try to animate this one, then your spindle will not rotate, because of which there will be no lateral motion. If there is no vertical motion, okay, if there is no vertical translatory motion, okay, then the screw jack will not be able to lift the load. Okay, so all those are related to the motion analysis. We will not worry about it. So our objective is only to get the orthographic views. That's why we are constraining the motion of one part with respect to the other part. Okay, so 5 parts have been assembled together, and all are rigidly connected to each other now. That's why it is showing fully defined here. So now I am going to insert components again, browse. Now I am going to bring the screw, so which will be placed somewhere here. Then go for clicking on mate option, select this cylindrical portion here. So then select this one. So make them which one? Concentric first. You can check it. You can keep it in isometric view. You can check now. So the screw axis is collinear with the axis of the body, or axis of the which one, washer, or axis of the cup. Okay, now so it has become concentric now. Then what I do is I want to bring this conical face of the screw in contact with this conical face of the washer. So I'm going to select those two conical faces of the screw and the washer. Then they will become coincident. Okay, means the distance between those two will become 0. Then click on OK. Okay, but when we do this, okay, still you can see now, still there is a possibility of rotation of the screw, as you can see here. Okay, so therefore we need to prevent this one. So in order to prevent the rotation of the screw, okay, so what I do is I am going to select the front plane of the assembly. Okay, so I'm going to select the front plane of the assembly, which is selected already in this mate selection option. Then I'm going to expand the part number 6. Now select the front plane, then give it OK. What happened? Okay, I think check. Let me check. Okay, it is taken correctly now. So the front plane of the, let me check it here. So this is the front plane of the which one? So here, as you can see here, this is the front plane of the screw, and this is the front plane of the assembly layout. So both have become coincident. Okay, so close it. So you can see now. Now also, if you try to look at the status bar, okay, all the parts that we have assembled so far are rigidly connected to each other. That's why it is showing here. It is fully defined, fully constrained. There is no motion possible between one part and the another part. That is the meaning of fully defined. It is fully constrained. Okay, so then last part that we need to assemble now is Tommy bar. So in order to bring that, go to insert components, browse. Okay, Tommy bar. So bring it to somewhere here. Then go to mate. Okay, select this cylindrical portion here. Okay, so this cylindrical portion of the rod has to be selected first. Then this inner surface. Then make them. So now what has happened is the axis of this Tommy bar has become collinear with the axis of these holes. Okay, is that clear? And then what we can do is we have to bring this particular circular edge. So let me zoom it here. This circular edge should make contact with when we insert it inside. Okay, this selected circular edge should coincide with this circular edge. So give it OK now. Okay, but again still we have a possibility of rotation of this Tommy bar about its own axis. So therefore, if you want to prevent that, you can see part number 7, that is Tommy bar. So this is its front plane. So this is the front plane of the Tommy bar, and this is the front plane of the entire assembly. So make them coincident. You can see now they are coincident. Give it OK. So therefore, when I click on OK now, you can see all the parts have been assembled together such that there is no motion possible between one part and the another part. This is very, very important, because if you restrict the motion between one part and the another part in the case of any mechanism, then there will be no motion transmission from the input link to the output link. But we are not worried about motion analysis here. Okay, but let me show it here itself. If you want to really understand how the motion will be transmitted, then in the status bar somewhere here you can see there is something called as motion study 1. You can do all those things, but that is not our objective. I am going to ignore that part. But if you want to really do the motion analysis, you should not restrict motions. You should not restrict the motion between spindle and the nut. If you restrict the motion, if you make the degree of freedom between spindle and nut as 0, okay, so then this mechanism will not convert any, it will not convert one motion to another type of motion. That is, rotary motion will not be converted into translatory motion, okay, or load will not be lifted like that. Okay, but for getting the orthographic views, you can go for rigidly fixing one part to the another part. So in the way that I explained now, okay, you can use these mate options. Different mate options can be used, and you can assemble the parts like this. Okay, so this completes the assembling of the parts of the screw jack. So let me fit it to the window. So let me show the top view. So this is how the top view looks now. So this is the front view. So if you want to see the right view, this is going to be your right view. This will be your left view. Okay, so like this, and this is going to be your bottom view. So this will be your top view. Okay, so and this will be your isometric view. And if you want to take the section about the front plane, okay, so this is how the section will come with respect to the front plane. So this is how it looks. Okay, so you can see that this is the body. Okay, so this is the nut here. Okay, so this is the screw spindle. Okay, so this is the Tommy bar. Here we have this is which one, screw. This is washer. Okay, and this is the cup. So you can identify all the parts when we take the section. Or if you turn off the section now, zoom out. okay, or zoom to fit, and then click in, keep it in isometric view, okay. And if you want to, when you keep it in a front view, if you want to see it in a wireframe mode, turn on the hidden lines visible. So this is how it looks, okay. Or you can even go with this. This is how it looks, okay. So different options are there. You can explore yourself. This is wireframe mode. This is hidden lines visible, hidden lines removed. Okay, when hidden lines are removed, it will appear like this. This is shaded mode. Okay, this is shaded with solid edges. Okay, so this is how it looks. So finally, I'm going to keep this assembly in the isometric view, and I'm going to save this as assembly. Assembly 1 screw jack. Okay, I have saved this file. But as I was telling in the beginning, our objective is to get the front view, top view and side view of this screw jack assembly, and also the isometric view of this screw jack assembly. Okay, but what we are seeing now is the 3D model, 3D model of the assembled screw jack. So therefore this is not the one we wanted. So what we do is we will close this graphics window now. Again, I will go to the new, and now first we created 7 individual parts, then we assembled together, and now we go for converting this 3D assembly into the drawing. Okay, so we have to click the drawing option now. Okay, then okay, now drawing layout will open. The moment when the drawing layout is going to open, wait for a minute. Okay, when the drawing layout is about to open, it will ask for us to select the sheet size, because whenever we want to, suppose if you recall your machine drawing, there in your machine drawing, when you are manually constructing the orthographic views, okay, are there views of the riveted joint, or the views of the threaded fasteners, or the views of the different assemblies. Okay, you are constructing all those views on the A2 sheet. Okay, but here we don't use A2 sheet. Okay, instead of that we go for using A4 sheet. But again, when we go for using A4 sheet, we can go for keeping the A4 sheet in the portrait manner or in the landscape manner. But here right now it is showing like it is portrait. So what I do is I will go for clicking on browse. So here there are different layout. So sheet layouts are available, like A0, okay, A1, A2, A3, A4 with landscape, like that, landscape and portrait. So here I will go for A4 with landscape. I will use this one. So now you can see it is the A4 size sheet is appearing in landscape manner. Okay, and I will click on OK. And here, whether you want this display, that is sheet details are required or not, it will ask. If you want, you can retain. Otherwise, you can turn off this display sheet format. Okay, so I will retain them. Give it OK. So this is how the layout will come. So this is the drawing layout now. Okay, so now once the drawing layout is opened, what you have to do is you simply close this model view here, close this one, then right click on this sheet 1 and go to the properties. As you have already learnt in your machine drawing, in India we are going to follow the first angle of projection, means always front view will be above the top view, that is below the front view we are going to get the top view. Okay, means above the XY line we are going to draw the front view, and below the XY line we draw the top view, that is first angle of projection. That is object is going to come in between the observer and the reference plane, that is the first angle of projection. That is what we are going to follow. So that's why you are going to change this type of projection to first angle projection first, and then click on OK. Okay, so don't forget this. The moment drawing layout is opened with A4 size sheet with landscape orientation, okay, close the model view, then right click on the sheet 1 properties, then change the type of projection to first angle, because software will always work with third angle projection, but we don't want the third angle. We have to limit ourselves for the first angle projection. Okay, so select the first angle projection. Then once you select the first angle projection, now you can go and click on this view layout. Okay, command tab. Okay, so view layout command manager tab, click on this, then click on model view now. So select the model view, then go and click on browse. Now we have to select the assembly file of the screw jack. So assembly file of the screw jack is here. So assembly one screw jack. Okay. So now when I'm trying to generate the orthographic views, so right now only one view is coming, as you can see here. As I am moving the cursor, only one rectangular box is appearing. The meaning is that right now the software can give us only the one view. Which is that one view? That can be seen on the left side here. So right now we are trying, okay, software is trying to give us the front view, but we need all the front view, top view, side view and the isometric view. That's why, so software will give us, since software is trying to give us only the one view, orthographic view, but we are interested in getting multiple views. So first you have to click on this create multiple views here. So once you click on create multiple views, okay, so which multiple views we require, that can be selected here. Okay, so first by default always front view is selected. Then I will go to the bottom one. This is the top view. Then this is the isometric view. I will select that. Then this is going to be my right view. Select that. Okay, so if you want the remaining three also you can select, but we don't require them. So only front. Okay, then top, then the isometric, and then the right. So these are the four views we are interested in. Then click on OK. Okay, so this is how we have got all the three views and one isometric view now. So now what I do is I'm going to drag this isometric view little bit to here. Okay, so isometric can be moved without any constraint, but when you try to move the front view, okay, because front view, side view and the top view all are dependent on each other. Okay, so their locations should be depend on each other. Okay, so once you try to move the front view, okay, the side view and the top view will also be adjusted, okay, automatically like this. Okay, so this is how we can show the front view. This is the front view, this is the top view, this is the side view, that is the right view, and this is the isometric view. And then we can go for saving this file. Okay, so as assembly one screw jack, and this file will be saved as a .drw, that is drawing file. Okay, save this one. Is that clear? So this is how we can show these views. So our objective was, now let me drag this to somewhere here. So let me drag it to somewhere here. Let me put this isometric view to somewhere here, because what I am trying to explain now is I will also add a bill of materials here, parts. Okay, all the 7 parts name should be listed, and how many quantities are used. Okay, that should be listed in a table. So in order to do that, what I do is I will go to the annotations, or let me go to insert here on the top menu, insert or the tools. Let me check it here, somewhere here we will get that option. Okay, I think I am unable to get those things. So it will be available somewhere here. When time permits, edit. So somewhere there should be option of tables. Let me check it under the insert. It is under insert only. It is, there is an option of table. You can go to the tables. Okay, here general bill of materials. You select the bill of materials. Okay. And it is asking select a drawing view to specify. So I am going to select this isometric view. Okay, and then it is top level only, give it okay, and then the moment you do it, you can see now. Okay, so bill of material has come, and description we have not added anything. So what I do is I will try to delete this particular column, and then you will be able to see. Okay, like this. Okay, so this is my bill of materials. So you can see there item numbers 1, 2, 3, 4, 5, 6, 7 are listed. So depending upon how we have saved the part files, like we saved the part body as the part 1 body, part 2 body. So therefore if you are not using part 1, then only, okay, so in front of item number 1 only name will come as body, okay, then nut, then screw, like that. So better if you want you just give the names of the parts itself instead of starting the part, starting the file name as a part 1, part 2, part 3, like that. Okay, so this is how you can go for adding the bill of materials. So but sometimes you may be asked to also show the which one, half sectional front view or the full sectional front view. Then what you have to do is, okay, so then what you have to do is there is an option here called as section view. So go to the section view. So here it will ask whether you require the section, full section or the half section. Okay, so which one you require, it will be asked. So I will first, let me show half section. Okay, so I will select the half section here and I will go with this right side up. Okay, and then I will select this top view. Okay, so I will click on the center of this top view here. Okay, so somewhere here, exactly here. Okay, here, click there, then give it OK, and you can see now we are getting the which one, off sectional front view. I am going to overlap this off sectional front view with the front view which is already available there. So I'm going to overlap manually like this. Okay, so this is how one can get the off sectional front view of the screw jack. But if you recall your machine drawing, okay, there are few parts or few machine elements which should not be sectioned. Okay, that is like shaft should not be sectioned. Okay, and the handle should not be sectioned. Okay, screw should not be sectioned here. Okay, and washer should not be sectioned, like that. But here almost the shaft, that is the screw spindle is sectioned, the handle is also sectioned, screw is sectioned. So therefore okay, this so software is going to automatically add the sectioning for all the parts. Okay, but theory says that these parts should not be sectioned. So if you want to really remove the sectioning of these parts, then okay, you have to right click here. Okay, you have to right click on that corresponding part and you have to go to the properties and you have to remove the hatched area. Okay, so manually it should be done. It will take so much time, so I will not go in detail about that, but try to remember only this much. So how to try to take the off section, okay, and how to insert the bill of materials and how to place the all the views. Okay, first you have to place all the 4 views here, 3 orthographic views and 1 isometric view, then bill of materials, then sectioning. Okay, so this is how you can go for showing the section. Okay, section for the section half section in the front view. Okay, so therefore this is the front view with the half section. Okay, this is the top view. Okay, and this is the right view, isometric view, bill of materials. Everything has been done now. So this is how one can make use of the modeling package to model the 3D parts and converting the 3D parts into 2D drawings. So this completes the modeling and assembling of the screw jack parts and generating the orthographic views. Thank you.